So this is Fourier optics, and this is the introduction to the Fourier optics. Application of Fourier techniques to the analysis of optical systems. So you see that here the main objective of our Fourier optics course is that we should be able to design any optical system, and we could be able to analyze the optical systems. So this is our main target. And you know that the Fourier optics will help us in order to explore, in order to analyze, in order to design any optical systems. So the Fourier techniques which we shall be using are based mainly on Fourier integrals. So we shall mainly be concentrating on Fourier integrals in order to design our optical systems. But there are other methods which we refer to as the equivalent Fourier based methods. So you see that sometimes the integrals will not be able, we are not able sometimes to evaluate the integrals, so we shall be using equivalent Fourier based techniques. The techniques will be the Fourier based, I mean that those techniques will be derived from the Fourier integrals in some way, and we shall be using those ones because those techniques will not involve the integrals, but they are basically the Fourier based techniques. Now the optical systems are mainly divided into two parts, a geometrical optics system and the physical optics. Now you know that in the geometric optics, when we talk about the geometric optics, we don't talk about wavelength. So no wavelength, it means no wave nature, it means no diffraction, and we shall be treating the light as rays. And rays mean that the line which are perpendicular to the propagation of wave front. So those will be referred to as the rays. So geometric optics mean very simple. No botheration about the wavelength, no botheration about the beam nature of light, no diffraction, and light will be treated as rays. So the simplest case or the ideal case is the geometric optics. So if we want to study anything in a pure ideal situations, we shall be talking about the geometrical optics. And you know that in geometric optics we shall be disregarding the diffraction. And the second, which is the physical optics, is mostly relevant, and you know that is the real optics that we come across in our life in the designing of our systems. And you know that we have to talk about the wavelength at which those optical systems are designed. It means that we are talking about the wave nature of light, and of course we have to talk about the diffraction. So you know that whenever we are talking about the wave nature of light, we cannot disregard the diffraction. We have to incorporate the diffraction in order to realize our physical system in reality.